Hey everyone, welcome back to the channel. Today we're diving into the fascinating world of semiconductor memories and the intricate processes behind their manufacturing. It's a topic that's at the core of our devices, yet often overlooked. So let's get right into it. First off, let's talk about how these tiny components that store every bit of data in our gadgets are made. Semiconductor memories like RAM or flash start their life in a highly sophisticated fabrication process. It all begins with silicon wafers, which are thin slices of semiconductor material. These wafers are meticulously cleaned and polished to create a perfect surface for chip production. Next, the photolithography process comes into play. This involves coating the wafer with a light-sensitive material called photoresist, then exposing it to ultraviolet light through a mask to create intricate patterns. These patterns are then etched into the wafer using chemical or plasma etching, forming the tiny circuits that make up the memory cells. After etching, various materials are deposited onto the wafer to build up the layers of the memory cells. This can include metals for electrical connections and insulators to separate different components. The doping process is also crucial, where impurities are introduced to modify the electrical properties of the silicon, enabling it to store and transfer data efficiently. But what happens after the tiny memory chips are crafted? That's where assembly and test, or A&T, comes into play. Assembly is all about putting those silicon chips into a protective package that shields them from physical damage and electrical interference. The semiconductor is placed inside a casing, typically made of plastic or ceramic, ensuring it can survive the harsh conditions of everyday device use. Imagine the precision it requires. These chips are microscopically small and extremely delicate. Next comes testing, arguably the most critical step. Each chip must be rigorously tested to ensure it meets the performance standards. This involves feeding it electrical signals and checking its response, ensuring no defective chip makes its way into your smartphone or laptop. The testing phase helps in identifying any potential failures, increasing the reliability of the semiconductor memory. Now, onto the big debate: insourcing versus outsourcing. Many big players in the tech industry face this decision. Insourcing means all this intricate A&T work is done in-house. The advantage? Greater control over the production quality and intellectual property. Companies that insource can quickly adapt and innovate their processes, which is crucial in the fast-paced tech world. On the flip side, outsourcing involves hiring external firms to handle the A&T process. This can significantly reduce costs and free up resources to focus on design and innovation. However, it also means relying on third parties for maintaining quality standards, which can be a risk if not managed carefully. Both strategies have their merits, and tech companies choose based on their priorities and capabilities. For instance, a company focused on rapid innovation might prefer insourcing to keep their secrets close and their processes adaptable. Others might find outsourcing a smart move to scale up production without heavy investments in facilities. So, there you have it. The complex yet crucial world of semiconductor memory production. Whether it's insourcing or outsourcing, each strategy plays a pivotal role in how efficiently and effectively our favorite devices operate. It's a blend of precision engineering and strategic decision-making that keeps our digital world running smoothly. Thank you for tuning in. If you found this insight into the tech behind our tech interesting, give us a thumbs up, and don't forget to subscribe for more content. Catch you in the next video.